Okay, so we I shouldn't say we, sorry. I made a little boo-boo on the example that we did yesterday, and I got away with it because we checked the answer and it was right. And so there you go. So let's go through 55 and 56 together, and I'll point out my own mistakes. The first part we're good. It says find the displacement over the given time period. So how do I do that? Take the antiderivative from where to where? Of 3t minus 5, okay. We're on 55. It's kind of crossed out. From 0 to 3, right? Okay, so the antiderivative of 3t, Logan, is? What's the exponent on the t right now? So add 1 to that, so you get 2. And then multiply by the reciprocal of 2, which is 1/2. So it's 3t squared, 3/2 t squared. Okay? Minus the antiderivative of 5 is 5t. And we're doing that from 3 to 0. So if you plug in 3, you get 9 times 3 is 27, divided by 2 is, what's 27 divided by 2? 13.5? Okay. Minus, if you plug 3 into there, you get 15. And then technically we have to plug 0 in there also, but that's just 0. So the answer to part A is negative 1.5. Okay, so that's all good. All right. Then I said, okay, that's the displacement, but to figure out the distance, you have to break it up into 2 pieces, one when it's moving to the left and one when it's moving to the right. And in order to do that, you have to take the velocity equation and set it equal to 0. And that's all still true. So if I take 3t minus 5 and set it equal to 0, what do I get? 5/3. Okay, so it changes direction at 5/3. All right? And so what we did is we set up 2 different integrals, one from 0 to 5/3, and the other one from 5/3 to 3. Okay, that's enough. Just rid of her. I'm trying to teach a class. Yeah, you can. Just hold it in. Yeah, if that's what it takes. No, I mean just like silently. True. Okay. Elizabeth, do you need some water? You okay? Okay. All right. I'm concerned about you, but have learned not to be. Your coughs sound like you're going to die in about 2 minutes, but apparently that's just how it goes. Okay, so what I failed to mention is when the particle is moving to the left, since we want distance to be positive, we have to take the integral not of 3t minus 5, but we have to take the integral of negative 3t plus 5. Because it's moving to the left, which is negative, and we want distance to be positive, so we have to switch everything around.
You found that out for the negative 1.5, right?
No, I found that out because Joa asked me why is my question wrong, and I did it, and I got the same answer, and so we looked in the book, and it said...
No, I mean, you know it's going to the left because it's negative 1.5, right?
No, I don't know it's going to the left, okay? I know it stops at 5/3, all right? So then really what we got going is this this little deal sign chart again, basically. I want to know from 0 to 3, right? And I know at 5/3 it's 0. So pick a number. 1. If I plug 1 into here, do I get a positive answer or do I get a negative answer? Negative. So that means it's moving to the left over that interval and moving to the right from that interval. Okay? So my integral from 0 to 5/3, I have to do the negative of this. And my integral from 5/3 to 3, I have to do the regular positive. Is that acceptable? Yeah. Okay. So instead of doing the integral from 0 to 5/3 of 3t minus 5, I'm going to do the integral from 0 to 5/3 of negative 3t plus 5. And then this one, like I said, since it's going in the positive direction, will stay as a positive integral. Okay? All right, so we did the antiderivative of this already. We just have to change the sign. So instead of being 3t squared over 2, it's going to be negative 3 halves t squared. And instead of this being negative 5t, it's going to be positive 5t. And then I'm still going to plug in 0 and 5/3. Did you happen to do this, Joa? Plug in 5/3 to that thing? Because it comes out to be, isn't it like 4? Okay, 4.16 repeating. So I'm going to let you, you can check that on your own, that when you plug 5/3 into here and squared and then blah, 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 that this is what you get. Okay. Then this antiderivative is going to match the one we already have. So this is going to be 3 halves t squared minus 5t, and this is going to be from 5/3 to 3. So when we plug 3 into there, we know already that we get negative 1.5, right? And then that's minus what we get when we plug 5/3 in there, which is 4 point, what's that? Negative 4. Oh, right, because it's opposite. Thank you. That would have screwed me up again, and I would have been super frustrated. So this is negative 4 1/6. So it's going to end up being plus, yeah. What does that come out to be? I don't know. No, really? Well, this is negative, I thought, though. Oh, because this is negative, so that's got to be positive. Okay. No, I don't like that. When you... There we go.
Oh, sorry, I just added the 2.
Oh, okay. So the bottom one comes out to be what? 2 2/3. Okay, and so we kind of cheated yesterday, and remember, I don't know if you remember, but I came out with a negative answer and a positive answer, and then we said that it was distance, and so the negative answer just became positive. And I thought we could still do that with these problems, but we checked and it doesn't come out to be the same thing. So this negative, changing it to be the antiderivative of the negative function takes care of that, distance has to be positive issue for us. So 4 1/6 plus 2 1/3, 2 2/3 is 6 5/6, which is 41/6, yeah. Okay, so if I add those together, I get a final answer of 6 5/6. Okay? How do you feel about that? That's a lot, I know. A lot of concepts, a lot of math, a lot of things. 6 5/6. Yeah, I know. I know. Yep, I get it. Yeah. But got to just keep going here. We're getting there, getting closer. Should we do 56 together?
Yeah.
Okay. Okay, so 56 says V of t equals t squared minus t minus 2t minus 8. And for this one, we're going from 1 to 6. Okay? So the first part, part A, is easy. You just do the antiderivative of this and evaluate it from 1 to 6. Did you get 68 1/3, Joe, for that? Uh-oh, disagreement. Okay, what was your antiderivative, Cameron?
1/3. Oh, wait, no, this is the one I went up on.
Oh, okay. 1/3 t cubed, and you have to say it that way, minus t squared minus 8t, and that is from 1 to 6. Okay? Then you put in 6. 6 cubed is 216. Okay? So, and that is divisible by 3. So that comes out to be 72. All right? So 72 minus 6 squared is 36. Minus 8 times 6 is 48. Minus, then I have to put 1 in there. That's easy. 1/3 minus 1 minus 8. What did you say you got from all that? You got 3 1/3? 3 1/3? Okay. Tiana, you got 3 1/3? Okay. Okay, so that should be relatively simple, okay, hopefully. Okay, now for B, this is where things get a little dicey. Oh, I didn't want the whole thing. What just happened? Huh? Okay, for B, now we have to first figure out what? Set it equal to 0. What? You got negative 3 1/3? Oh, you did? You didn't tell me that before, Tiana. Negative 3 1/3, 3 1/3. I owe you $3, you owe me $3, whatever, it's no difference. Okay. Cameron, we got negative 3 1/3. Yeah, we just forgot to put the negative there. Okay. Word of the day is piccolo. Okay, so what do I have to do first? Set it equal to 0. Right, so in order to do that, I have to factor it. Okay. Yeah, you are. Okay, t equals negative 2 and 4. All right, now we don't care about the negative 2 because it's not in between 1 and 6. Okay, so we're going to look at this integral from 1, or this interval from 1 to 6, and we know that it changes direction at 4. So you want to plug in 3? Okay, so if you plug in 3, this one is negative, this one is positive, and negative times a positive is a negative, so it's going to be negative here and positive there. Okay, so that means I'm going to do the integral from 1 to 4 of the opposite of that, yeah, negative t squared plus 2t plus 8 dt. And then I'm going to do the integral from 4 to 6 of the regular one. And I'm going to get those two answers. They're both going to be positive because I switched the negative one to be negative already. Add them together, and then I'm good. Okay? So do you guys want to work on that for a minute? Do you have it already, Borski? Tiana, you have it already? Joey, you have it already? Colby? Not so much. Cameron, working on it? Okay. Jake, working on it? Logan, working on it. Okay?
So from 4 to 1,
Uh-huh.
can we just change what we got to 1 to a negative number, or to a positive number?
Don't you think?
Yeah, so it's negative 8.3.
So you mean, so you came up with the antiderivative, you got negative 1/3 t cubed plus t squared plus 8t. And what you're telling me is when we plug, what? Isn't it plus? Because it was minus before? Yeah, okay. Okay, so what you're saying is when we plugged 1 into here, we got,
Negative 8.3.
so you want to just switch that around and make it positive? Seems like it, but I feel like that's what I was trying to do yesterday and then somehow it didn't work.
Well, it worked up here.
Yeah, so try it. The only thing I would be worried about, and maybe that's why it failed, no, those are positive, I don't know. So you made this one, okay, I'll just let you figure it out. And then you can check it with Tiana's work and see if we're right. Did I only give you guys 2 problems to do? Oh. What were 57 and 58 about? Oh yeah, I remember that. Okay, did you have questions on those, or you got those okay? Tiana, you have questions? Yes? No, you got it. Joe, did you get 57 and 58? No, so let's find your simple mistake. So we had this as our antiderivative, right? Yes? Okay, and then when you plugged in 4 for t cubed, what did you get? 26 and 2/3, that's where you made your mistake. 4 cubed is 216. Oh, I meant just for the very first term. Yeah. Okay, you got the whole thing. Okay, so if you put in 4 there, you get 216 divided by 3 is 72. So this is negative 72, right? Okay, plus 16. Yeah, you might have. Oh, for the very first one? Right, okay. Okay, so we'll just call it good. We'll just assume that you could do it. You just had a simple math mistake there. Okay. All right, so we talk about 57 or 58. Just real, you good, but I'm going to assume maybe Logan or Colby needs a little boost on that one. Not trying to be insulting, just, you know, it's basic statistics. Okay, so this time we're starting with the acceleration. And we want to figure out what the velocity is and then do all the same things we did in the other deal, okay? So if I have the acceleration, how do I find the velocity? Antiderivative, right? So I need to do the integral of t plus 4 dt. So what'd you say? Okay, 1/2 t squared plus 4t plus c. Yep. And then we know that so that's the velocity equation. And we know that when that is, when t is 0, the velocity is 5. So if you plug in 0 for t, what do you get for c? 5. So c equals 5. So that means our velocity equation is actually 1/2 t squared plus 4t plus 5. Okay? Okay, so bummer. Now we have, that's the answer to part A. Now we have to find the distance traveled. So we have to do that same thing that we did before. So to set that equal to 0. Yep, the equation we just found to see when it's changing direction. So I'm going to say maybe quadratic formula on that because of the 1/2 kind of freaks me out a little bit. T squared plus 8t plus 10. Yeah, I don't have a... You should be. Okay, I was hoping you would say that. Negative 1.55 and negative what? Okay. So the nice thing about those two answers...
You get negative 6.45? Yeah.
The nice thing about those two answers is that neither one of them is in the range 0 to 10. So that means the particle does not change direction in this time period. So we can just solve this problem by doing the regular old... well, it turns out to be irrelevant, but we had to...
0 to 10.
Yeah, 0 to 10. That was a bad 0, apologies. Of 1/2 t squared plus 4t plus 5 dt. I know, but it's really good because I listened a little bit to the recording yesterday, and it just is really clear, and I don't have to like over project or anything. You know what I mean?
Do you hear us through it?
A little bit can pick you up a little bit. Like if I really turned it up and I wanted to hear what you were saying, then I could hear you. But even before, I don't know if you guys remember when the microphone was in the computer, then I had to always talk like really, well, you know, just to get it to be there. Now I can just be myself. Yeah. Yeah, Mr. Pugh said he could probably find me a wireless one, but I don't know, whatever. Yeah, I'm on board all the time. Right. Okay, so then you plug in 10. Oh, no, we have to find the antiderivative first. We didn't even find the antiderivative. No, we found the antiderivative of acceleration to get us the velocity, but we are trying to find the distance traveled, so that's the antiderivative of the velocity. Yeah. Okay, so this is going to be 1/6 t cubed plus 2t squared plus 5t from 0 to 10. If I plug in 10, I get 1,000 divided by 6 plus 200 plus 50 minus 0. What's 1,000 divided by 6, do you think? 66 and 2/3? Thank you. You do, yeah? Pretty safe bet. So that's going to be 316 and 2/3. What's 1,000 divided by 6? Oh, 166. I didn't hear the 160. Sorry. Wow. So it's 416 and 2/3. Yep, final answer. Then we would have had to do like we did on the last two problems, break it up into two integrals, one of them being the regular one of them being the negative one. So that's why I was really happy when you said negative 1.55 and negative 6.45. So hopefully that's the same for 58. Let's give it a go, shall we? Oops, I shouldn't do that probably. So 2t plus 3. And then we know the initial velocity is -4. And we want to go from 0 to 3. Okay, so to find the velocity, I have to take the integral of 2t plus 3, which is, I'm not feeling the 2/3 t squared. I'm not feeling the 1/3 either. It's just t squared plus 3t plus c. But then when we plug in 0, right, c is going to be 4. Is that fairly obvious? Okay. Oh, -4. Not that obvious. Turns out to be not very obvious. What? So then I can, so that's the answer to part A, that the velocity equation is t squared plus 3t minus 4. And then for B, yeah, or that one looks like you can factor it. Plus 4 and minus 1. Is that right? Okay, so that means it's going to unfortunately equal 0 at -4, which we don't care about, but it's also going to equal 0 at 1. Yeah, so it changes direction inside our interval. So that means we have to break this down into two different ones. The integral from 0 to 1. Is it going to be positive or negative in between 0 and 1? Positive? Right, so I'm going to go 0 to 1 of negative t squared minus 3t plus 4 dt. And then I'm also going to do the integral from 1 to 3 of the regular. Yeah. Figure out what those both are. They should both be positive. Add them together, and that's your final answer. What's that? Yeah, right. So the bus just went by. Did you guys want to, in the fire truck, did you guys want to go out and say to the girls, hey, good luck, bye? Okay. Girls basketball leaving. Why are they leaving so early today? They're practicing today, but you would think that they could still leave it, right, and get over there and practice. I always wonder that about fast pitch also. Fast pitch does the same thing when they make it to state. So state starts on Thursday or something like that, right? And then they leave Wednesday morning before school even starts, and then drive over there and it's like, I mean, I get it that they practice that day, which is important, but that's absolutely not true about boys golf. We have our practice round in like Spokane, and it starts at noon, and so we leave at 5 a.m. that day and drive over there, and then yeah, it's brutal. Apparently, if we were any other sport, we'd leave the night before, spend the night, and then go to practice round.
Why not you do it?
Because it's golf, and nobody wants to pay any money for us to do anything. Same with tennis, right?
Yeah.
Huh? You thought about doing tennis. Okay. Okay, so the antiderivative here is negative 1/3 t cubed minus 3/2 t squared. Okay. Plus 4t. No, because I'm doing the opposite one.
Oh, okay, sorry.
That's okay. I appreciate you keeping an eye out for me. I make plenty of mistakes. So negative 1/3 minus 3/2 plus 4. This is going to be negative 2/6 minus 9/6 is negative 11/6 plus 4 is 24/6. So that's 13/6. So is this 2 and a 6? Okay, then this one, the antiderivative is the same, except the signs have been changed to protect the innocent. So if you plug in 3, you get 9. Minus 9 times 3 is 27, divided by 2 is 13.5, minus 12. Minus what you get when you plug 1 in, which unfortunately we can't say is 2 and 1/6. It doesn't work out that way. Minus, plus. Whew, so many places to make mistakes. Okay, so then if I plug in 1, I get 1/3, 3/2, and negative 4. So this part works out to be 1.5, 10.5. This part works out to be 1/3 plus 3/2 is going to be 11/6 minus 4 is, so it did work out that time. So sometimes it's going to and sometimes it's not. Okay, so 1/2 plus 1/6 is 3/6 plus 1/6 is 4/6 is 2/3. So this is 12 and 2/3. So if you add those together, you get, as advertised, 14 and 5/6. Right?
And if you would have gotten a negative answer for one of those, you would have turned it into a positive.
I think so, yeah. And you would have been okay. Which is what I tried to do yesterday, and I thought that was going to work, and then Joe came in and totally shot everything down. Okay, yeah. So no homework. We're not going to start a new section today. We will do that on Monday. Okay. Come back, Caleb and Brooke and Mackenzie. We miss you.